Good morning, everyone. My name is Emma Truitt. I am one of the municipal stormwater permit writers with Ecology, and I will be moderating this session titled Puget Sound Watershed Characterization Project with our speaker, Colin Hume. This is going to be formatted a little different than some of our other projects where sessions, excuse me. Colin has a few breaks throughout the session for you to stop and ask questions. So be sure to just write those questions in the chat whenever they pop into your brain so that we can facilitate those breaks. All right, go ahead and take it away, Colin.
All right, thank you, Emma. Good morning, everyone. I really appreciate the opportunity to present at the workshop today and give you guys an idea of the tools available from my team and the project that we're going to discuss today called the Puget Sound Watershed Characterization Project. I think there are a lot of ways in which we can support your work on the stormwater management action planning processes that you're going through. Again, my name is Colin Hume. I'm Puget Sound Recovery Lead for the Shorelines Environmental Assistance Program at Ecology. And I have a small group of folks that I work with on bringing these spatial tools to land use planning. Again, like Emma said, feel free to type questions as you have them into the chat. We'll pause a couple of times to try and field some questions because this is a longer presentation. We have just over an hour for it. And so I think it'll just flow a little bit better, but I may push us along if we get bogged down too much because I do want to get through all the content. So thank you very much. And we'll start now. Today, we're going to provide a brief overview of the indices, the Puget Sound Watershed Characterization Indices that are available for use in many different applications, and we'll kind of discuss the range of those, but certainly in your SMAP processes. I'm going to illustrate an example from years ago with the city of Mukilteo, which really touches on many elements of the current SMAP process. So that'll give you some ideas about what has been done out there that is similar. And then really touch upon the very specific areas of your SMAP requirements where the information, the data, the technical assistance we can provide can be helpful, we think. So, and then discuss how to go about getting that technical assistance. Just start from the basic sort of framework of how we approach providing this information and land use planning in general, as well as more broad recovery planning, and certainly important for stormwater planning as well. We start from a process-based approach where we need to integrate information from broad, mid, and fine scales to deal with the interrelationship of process and structure and function across our landscape. So when we talk about broad scale processes, we're talking about the movement of water and sediment, kind of at that watershed scale, materials throughout the landscape. When I talk about mid-scale, we're talking more around sort of the structures and such as a stream channel or estuary or delta that are important for the function of things like habitat for birds or for salmon, bugs, etc. So the interrelationship of process structure and function is key to how we bring this type of information and how we assemble this information to inform things like land use planning, stormwater planning, etc. So the integration, kind of another way of looking at this, when we work through a planning process, we are bringing broad to mid-scale information from the type of tools that I'm going to illustrate today, integrate them ideally with more sort of fine scale data, maybe more modeled data, predictive modeling, or site-specific data. But what we really provide are these broad and mid-scales, if you will, types of information. And ours are a set of spatial indices, of course, but there's other ways of assembling that kind of information Ours is really that core scale data on land cover, land use, geology, precipitation, topography. And we're looking at identifying parts of the watershed which are most important areas that contribute to those processes. And we're talking about, again, this movement of water, sediment, nutrients across the landscape. The other information as we work through a full sort of planning process is bringing in that fine scale data that more quantifies, say, hydrologic flows or the site-specific biological, physical, and chemical conditions at that site scale. If you bring that information and integrate it across scales, we think that you will have a more refined understanding of the watershed processes as they apply to site scale decisions. We're going to describe, first go into our broad scale indices. We have 2 volumes that were established back in 2012 and 2013, building upon a lot of work. So the Department of Ecology published volume 1, Stanley et al. 2012. There's a newer version, 2016. And then the Department of Ecology by George Wilhare published volume 2, which is a series of terrestrial, freshwater, and nearshore habitat indices. We're going to focus today on volume 1, the water flow and water quality indices. There's a couple of reasons, and we'll go into that. Part of it's time, part of it's the ability to work with this data with jurisdictions in a more sort of tailored format. But there are a series of DFW indices that are available for use at certain scales, and that'll become clear kind of what that means. We have a volume 3, which brings both of those 2 volumes into sort of a similar framework and presents them, and the website that we have, which I'll show you, give you a demonstration of in how you start to integrate these different spatial indices in planning processes. So the broad scale indices, they utilize, at least out of the box version, utilize readily available spatial data that is consistent in resolution across Puget Sound. That was a necessity to provide something at the extent of Puget Sound. We couldn't just patchwork data from different locales together. So it did sort of set us down certain paths of the type of data that we could use. We can bring in and do local data sets into our index calculation frameworks. It's a bit more work, but that is an option in some cases to do that. Ultimately and fundamentally, our indices are relative comparisons of watersheds, and you're going to hear the term assessment unit. It's a spatial watershed unit that we have created for this purpose, and is at a different scale than things like a HUC or some of the things that might come out of like a ARC hydro tool. So we're going to be talking about this relative comparison, these indices that compare watersheds, and we're going to go through the water flow and water quality process indices, which assess the presence of indicators for controls on watershed processes, as well as the degradation of indicators for controls on processes. The habitat indices produced by DFW really look at presence of species, quantity of habitats, and things like the potential to impact downstream habitats if there are intense land uses in a given watershed. We aren't going to go into those today. Happy to talk with anybody that's interested in them or point them towards DFW and George Wilhare for more information around those indices. Recently published version 2.0 of the Water Resources Assessment as an addendum to volume 1. We brought in some new data layers and crafted a new assessment unit, which I think might be important for some locales to consider using if you're going to start building on or use our assessment units, which are referenced in the SMAP guidance, and some tweaks to how we calculate the overall water flow index. We're in the process of updating the water quality indices, and I anticipate them being online with the most current land cover data feeding into them, and that'll start to make more sense as you see what the indices are in the next couple of months. So those are an option to use in your SMAP process. The DFW, and this is partly why we're not presenting on them today, is DFW is not planning on updating the volume 2 indices. So there are implications for how kind of current that data is going to be. I think there's still value to them because the things that they are assessing in these indices are fairly robust in terms of like not disappearing from the landscape very readily. But we aren't able to kind of tailor them and to different delineations of watersheds, and that'll make more sense, like we are able to do with the water resources assessments. So won't be covering those today. Here is an illustration we'll kind of come back to a couple of times. So the stormwater management action planning requirement in the 2019 phase 1 and Western Washington phase 2 municipal stormwater permits have a receiving water condition assessment. And there are kind of 4 buckets of activities. There's some interrelationship amongst them, but 4 buckets of things that you need to do to end up with a prioritization of catchments for further focused analysis. So we're looking at that: delineate all basins and identify receiving waters, assess receiving water conditions, assess stormwater management influence, and assess relative conditions to end up with that prioritization of catchments. I'm going to go into the first step, which is really where you kind of have to start, is delineate all basins and identify receiving waters, and talk about how we can plug into that part of your process. Here you have what I've referenced before, our assessment units produced for all of the Puget Sound Basin. Again, it's a smaller scale than readily available HUCs or other types of delineations of watersheds that are out there. This is our out of the box, if you will, and you'll hear me reference that a lot. This is available for download. These are, and I'll give you some size ranges here in a little bit, but it is certainly, there's nothing like this product out there. And so I think there's some value to that for people planning in Puget Sound. This is our version 1.0 assessment units, and we have since then produced a second version. They're both versions, and I'm going to illustrate the difference. Both versions have their value and are an option to use in your SMAP process as a starting point, or maybe it might just apply right out of the box. But they both have their value, but they're different, in particular in the floodplain areas. And so I'm going to illustrate what that difference looks like. So here we have no floodplain units, but I'm going to zoom into an area of Raya 7, the Snohomish Basin, where it'll illustrate kind of what we did here to produce these floodplain units. Here is the confluence area of the Snohomish and Snoqualmie. You'll see those assessment unit boundaries outlined in teal. What I've just put on here is an overlay of a modeled sort of high floodplain or geomorphic historic floodplain that came out of some work that USGS did, came out in 2015 by Chris Conrad. What we did is we took this, it's kind of like a valley wall to valley wall floodplain, and we took this and overlaid it with our assessment units and essentially started drawing the edge of some of our assessment units along the valley wall to kind of more isolate the floodplain areas from the upslope areas. I'll flip back and forth just a couple times so you can see that difference there. It's subtle, but there are some differences that occur in the index calculations with the use of this floodplain unit. They both have their value and approach these low topography floodplain areas in a slightly different way. But we like this new version, and I think some jurisdictions in more of our floodplain areas should consider using these, at least as a starting place for your delineation phase. This is what it looks like, the version 2.0 with the floodplain units. You can kind of see, if I showed you and flip back and forth between the full map version, those floodplain areas kind of popping out a little bit. Size ranges give you sort of a sense of what that is. We use different landscape groups in our index calculations, and I'll go into what that means in terms of our actual indices. But they also have our landscape groups also have different sort of size ranges of assessment unit, and with the larger assessment units being in the mountainous area or that green area of the Puget Sound Basin, the smallest being in the coastal. These are a little bit hard to see, but there's a kind of a narrow band of pink coastal drainages that are a landscape unit. And then our lowland is in yellow and has sort of an in-between range of size. I'm going to show you guys an example, very recent example of what we can do in terms of providing technical assistance to delineate watersheds that are irrespective of the assessment units that we provide sort of out of the box. This is a project we've taken on with the city of Bainbridge Island around a watershed plan for Manzanita Creek. So Manzanita Creek outlined in pink here on the north end of Bainbridge Island. This is likely to fulfill parts of the SMAP requirements potentially, and they're also looking at a feasibility study for stormwater control transfer program to direct some credits towards this watershed, which is very important for salmonids and other critters on the island. So here's so this is a good example of what you can get when you kind of just press go on an ArcHydro tool to delineate watersheds. This, I think, provides a good starting place, but in terms of providing you with kind of good management scale watersheds to prioritize and compare and develop strategies for, there's some challenging parts to it. You can see the lines down here in this low relief area in particular were challenging. So my team worked with the city to adapt this. We came up with sort of a draft version looking at it's kind of the best stream data there from Wild Fish Conservancy, from their stream typing work that they had done there. So it was great to have that kind of information instead of having to just rely on NHD or other stream layer types. So we took this to the city and we had them convene a partner kind of feedback session across their project team. And through that session, which we participated in, we came up with a different delineation based upon recommendations from folks that know the watershed better. So I'll kind of toggle back and forth. Not too many changes. We kind of had it pretty well nailed with our first go at it, but a couple significant ones. That's the kind of technical assistance we can provide in terms of the delineation phase. I can pause here real quick, Emma, if there's anything kind of related that's popping out to the assessment units or our upfront part of the presentation, go ahead and toss that question.
Yeah, we do have one, and I think it's talking about the two versions, because he's saying, doesn't that distort the upland portion of catchments that are now disconnected from the receiving water?
So yes,
it says, yeah, with regards to the intersect of the AU and USGS floodplains.
If I understand the question, yes, this is why I think that there are some reasons to, so dealing with it's a great question. Dealing with the floodplain areas has always been kind of challenging. And in our version 1.0 assessment units, we really did our best to kind of follow a tributary all the way down to a main stem. It gets really challenging to do that comprehensively across Puget Sound. But yes, if you are trying to approach your receiving water assessment and you're in a kind of a main stem area, it may be more appropriate to use version 1.0. If you are not, or if you want to look at sort of floodplain, influences or influences to floodplains, there may be places where the version 2.0 assessment units could be more appropriate, but that's why I want to make sure and present both. Good question.
And that looks like that is all that's in the chat right now.
Excellent, cool. Yeah, great question. So here we're going to touch on elements of actually get into the indices, which are where I feel actually touch upon the assessing receiving water conditions as well as assess relative conditions, parts of the receiving water condition assessment. And so it'll kind of blend across those two, but we'll come back to this and get real specific about which indices I think play into very specific those individual phases of the SMAP process. Back to this image of the landscape groups is important. We're talking about our out-of-the-box results where we actually normalize. So because they're relative comparisons, a relative index, when you assemble a bunch of different spatial data with different units and stuff like that, normalization is a pretty standard way of dealing with that by comparing an assessment unit score to the maximum possible score across the extent of comparison, if that makes sense to you, from those that think about index creation. So the out of the box results, and we can do this in different ways, but what we provide just for download does normalize in our importance models. So for water flow and water quality, we have an importance models that we'll go through. We normalize by landscape group. So we're comparing only assessment units within a given landscape group. And then within that RIA, for the degradation model, we don't normalize by landscape group. This will start to make a little bit more sense. Again, we can approach this in different ways and do often with other projects. In our overall water flow model, we're really looking at the sort of pre-development conditions, if you will, of sort of those intrinsic characteristics of watersheds. And we organize the indicators of water flow processes around kind of three main buckets: the delivery, the movement, and the loss of water from the landscape. So under delivery, we're looking at things like average annual precipitation, the presence of rain on snow areas, which may not be an issue for many jurisdictions. Then under the movement of water, we're looking at areas of storage of water across the landscape. So using data on depressional wetlands and lakes, or unconfined and moderately confined floodplain areas that can store and slow down water on the landscape. And then we are looking under recharge and discharge of water. We assess high permeability deposits and the average annual, kind of with a regression formula from USGS, the average annual infiltration of quantity of water into potentially groundwater deposits. And then we look at highly permeable deposits on floodplains and slope wetlands to assess discharge. We don't assess the loss of water with this importance model, because all the areas are assumed to be forested and have equal evapotranspiration in this non-development impact side of the model. Here's what it looks at a RIA scale, where we take that assessment unit scores, which end up in a 0 to 1 range, and then we quartile them. The darker blue popping out here are lower floodplain areas, Snohomish, some of the upper watershed areas where there is a lot of more average annual precipitation is kind of driving some of those results in terms of being the most important for overall water flow processes. On the degradation side of the equation here, we are looking at really impacts of development. So underneath the same framework of indicators, we're looking at presence of impervious cover or forest loss. We're looking at where depressional wetlands have been lost to urban and rural land cover, loss of floodplains. Under recharge and discharge, we're looking at loss of recharge from urban land cover and loss of discharge from floodplains and slope wetlands, and the impacts of roads and wells. And then we do bring impervious cover into the loss side of the equation as well. So a lot of indicators really based upon land use type for the most part. Here's what that looks like. Again, just kind of at a RIA scale, at a Snohomish Basin scale. No surprise to those that know this area. Your I-5 corridor, suburban areas, and Everett are the most highly degraded. You do have some high levels of degradation in some of the floodplain areas that have been that are heavily farmed and have rural residential areas as well. And kind of the fun part about having these two variables of importance and level of degradation in being assessed for the same assessment unit is you can look at them in this kind of matrix approach where you look at the score for an assessment unit on the level of importance, put that on a vertical axis, level of degradation on the horizontal axis, where the highest an assessment unit that is scoring highest for the level of degradation and is at the lowest level of importance might be the most appropriate area to locate development. This terminology comes out of where we really developed the information, why we developed the information, which was given. My program works with a lot of land use planning. We deal with Shoreline Management Act, Growth Management Act sort of stuff. That was the impetus for developing this, and so we really were thinking about this in terms of how do we inform our growth patterns across the Puget Sound to least impact watershed processes. And so that's why we have something like a matrix category being development restoration, with the idea that if we have to accommodate people, we should put them in the places that are most degraded and least important to water flow processes. But really, this is just a way of looking at the score of an assessment unit for two different variables. And so in the top left corner, you've got an assessment unit if it scores highest for level of importance and lowest for level of level of degradation. That would be an assessment unit that you really want to focus on sort of protection-based strategies. If you are highly impacted, so high levels of degradation and really high levels of importance, you want some broad sort of landscape scale strategies to be trying to restore areas of those assessment units important for water flow processes. So that's the kind of construct that then you can map for, again, RIA-7, Snohomish Basin, and look at how the patterns of where you've got areas really important for restoration, like in our floodplain areas that have been highly impacted and are super important for water flow processes. Some of our upper watershed areas, certainly there are some impacts up there. They're very important for especially things like the delivery of water onto the landscape, and there's varying levels of degradation across some of those. There's some timber activities that are lowering the scores there and stuff like that. But in general, protection-based strategies are what you would want to take on there if you're trying to prioritize at this sort of high planning level. I'm going to go through this water quality example, and then I'll pause again for questions about the indices. So on our water quality process models, we've got a really similar construct. We've got an export potential, or i.e. sort of an importance index, and then a degradation index. And the export potential is assessing, again, irrespective of development, how readily an assessment unit might deliver materials to downstream waters if it's disturbed. So it's looking at source sink calculations for given materials. Our degradation model uses a predictive pollutant loading model from NOAA called NSPECT, and we use that to assess the level of degradation by essentially running the model on a hypothetical pre-developed landscape, running it on the current landscape with current land cover, and then assessing the difference between those two model runs to get at a relative level of degradation from historical conditions. Again, we can combine those into a matrix for general management strategies like we did for water flow. Just using one as an example, sediment, the export potential for sediment processes, we'll kind of run through the three versions of those maps. But again, a source sink concept here, we're looking at areas of surface erosion, mass wasting, or channel erosion in an assessment unit and scoring it for the presence of those areas. And then looking at the areas that might be sinks or could entrain, sediment in the assessment unit to get at this source sink calculation. And we're using, basically the storage results from water flow in that sink calculation for sediment. Here's what it looks like when you map it from high to low in the Snohomish. I think probably not surprising to some folks that some of our higher slope areas with high channel density, et cetera, are more likely to generate sediment if disturbed. Just want to give you an idea before I show you the degradation index. This is kind of the raw results of that inspect pollutant implosion loading tool. This is not sediment because sediment really is kind of it doesn't illustrate real well. So let's pretend it's sediment, but it's not, it's nitrogen. And so you get these, pixel level loading values by using an event mean concentration coefficient per land use type and modeling a 24-hour storm on the landscape. Imagine that was sediment. This is the how we use that when we again kind of take those two different grids and get the change from historic conditions, and then calculate the relative change across and assess and compare those across the assessment units. This is the Snohomish degradation model results. And looking at those in kind of the two-axis matrix way, similar to the water flow model, you can kind of get at some general management strategies where those areas that are highly important, i.e. Could generate a lot of sediment, but are more intact or less degraded, where we should protect those sources from getting exposed, and say like timber activities or things like that in the mountainous areas. Focus on those protection-based strategies to prevent sediment from moving at an unnatural, kind of beyond natural variation rate into surface waters, or the opposite, where it's highly degraded and maybe less export potential. Restoring sinks for those in those assessment units might be your strategy. I'm going to bring up a principle here that we've been working with, because I'm going to start to tie these degradation indices into things that I think that I know are very important in the stormwater world. There's some work that was coming out of the East Coast by Paul et al. 2009, where you start to look at along any kind of urban gradient. You can call it whatever, assess it in different ways, be percent impervious or whatever, but along any urban gradient, a biological index will have a wedge-shaped factor ceiling relationship, where there's going to be a lot of variability, especially at the lower levels of urban gradient. But as you do get higher up that urban gradient, there's some limits to what you can expect a biological index, or in the case that we worked with, benthic index of biotic integrity scores. And that can be calculated what that sort of ceiling is by using the 90th percentile regression line along that urban gradient. So looking at what really is the limiting, the potential limit of scores on a given urban, say percent impervious surface or percent urbanization. Here's just an example. We assessed for over 1,000 BIBI delineated basins with median scores. We ran our degradation indices, and this is just an example. All of them basically looked the same across water flow, water quality, that we did get that wedge shape factor ceiling relationship. And so our degradation indices with our broad scale degradation indices, you can make some assumptions, especially at the higher levels, for maybe limits to bug communities. Again, limitations on the broad scale indices. These are core scale data, really planning level information, and some people want it to be more precise or accurate than it can be. Doesn't measure rates or quantities for processes and functions, but we do use some regression equations and rates and stuff like that in the underlying kind of calculation of the indices. But the index score itself is not an indicator of that. Can't really use this information to design mitigation or restoration projects. It can be informative in those in terms of asking, kind of begging some questions to be asked of maybe the long-term viability of some of those decisions given the surrounding watershed contacts, but it's not a design level product. And this type of index is pretty difficult to validate. There's some ways, similar to kind of the BIBI thing that I just showed you, where the score can make some sense, but kind of a rigorous validation in a relative index like this is pretty challenging, and it's based upon the literature and best professional judgment of technical experts we have brought to bear on the project. I'm going to pause there, Emma, for any questions about the indices that may be out there.
Yeah, we have a few questions. One asking if you could clarify, again, the difference between restoration development and development restoration.
It's really just some terminology. I mean, frankly, it's really just looking at where it's trying to provide a gradient. I mean, so really restoration development means that assessment unit scored in the, not the lowest, but the moderate quartile for level of importance. Really, it's just taking those quartiles and assigning them a matrix location in this. Another question? Yeah.
Does NSPECT include effect of BMPs, include the effect of BMPs?
No, it does not. It's really looking at just land use types. And there are some coefficients for land use types. Good question.
Yeah. And then there is one more, but I think it's better suited for the end. So
sweet. Good questions. Thank you.
Yeah.
Okay, so here's just a range of applications, and we'll of course dive into this more stormwater one here. But we do a lot of comprehensive planning, technical assistance, and critical areas ordinance, sub-area planning. So really, kind of what this was developed for, land use planning, and but we do see such a great tie in terms of some of the permit requirements and how they can affect and improve land use planning. I think it's a great thing. Transfer of development right strategies, in lieu fee, wetland mitigation strategies, and then a number of SAM recovery related watershed planning applications. There's more than this for sure, but just a little sample. I'm going to run through this Mukilteo stormwater planning example. This was one of the first projects that I helped support when I came on in 2012. The city got a grant to that was focused on protecting and improving stream health and to develop watershed-based stormwater management strategic plan. And there was a part of it was meeting MPDS permit requirement at the time. And I'm going to call out kind of here as we go, as I go through the project. This is pre-SMAP, but I think there's so many similar elements to the current SMAP requirements. I'll kind of try and call those out. But here's in your delineation phase. On the left side, you're seeing the assessment units kind of are out of the box assessment units, which were kind of at too broad of a scale to help the city in their planning. So they basically, working with the consultant team, subdivided our assessment units to create, I don't know, maybe 2 or 3 times more assessment units. I haven't counted them recently, that they thought would better provide better management strategies in their ultimate kind of long-term product. This was an example of here where they actually were integrating our indices with some local data, still organized around that that water flow framework that I described to you before, taking our importance scores, but then creating their own degradation score. They called it an intactness score, bringing in cities' impervious surface data, some city and county wetlands, stormwater infrastructure, stuff like that. So this is really your assessing receiving water conditions phase, where you're getting at that landscape scale data to explain and predict receiving water conditions. This is another approach to that restoration protection matrix, and we use it. We've adapted it in other applications, but essentially they're plotting the score for their importance variable and the overall flow intactness score, which is kind of inverse to how we do it, where the higher that score is, the more intact it is, as opposed to the higher the score, the more degradation, the higher level of degradation is being assessed. So as these individual little watersheds each are organized around their bluff, plateau, or ravine areas, that's what the symbol is. But they saw, kind of a band of watersheds that all kind of hit about the same score here in the middle, but a couple that popped up in the highly important and more degraded, if you will, kind of category, and then a couple that popped out in the more important and more intact category, where they want to focus on protection or preserve sort of strategies and repair strategies. This is what that looks like mapped across the watersheds of the jurisdiction. And here they produced kind of summary sheets for each of those little project assessment units, is what we usually call them, where they're bringing some of the information, kind of the underlying scores from the index calculations into a more maybe sort of refined strategy, where these key management strategies will address different parts of the water flow process. And so they are called out here in these kind of detailed sheets. Then they also get at existing kind of land use constraints and stuff like that, that you're not assessing with this spatial data. So each of those little project assessment units has a summary sheet. And then the follow-up phase, which is not really, it was outside the grant that I worked on, but essentially the city, got another grant to do what I would call really after you've done your prioritization, your receiving water assessment, the stormwater management action plan, where it's really drilling into a couple of catchments to do a more detailed analysis and looking at where the areas are without flow control treatment or other types of treatment, where there are maintenance problems, flooding areas, what have you. And so really getting at a finer scale of analysis for certain priority catchments. Let's see, I will pause real quick to answer any questions about Mukilteo.
Yeah, we've got just one right now asking if you could clarify the size of the Mukilteo assessment units.
Oh, geez, I can't. If we look back, ours in this context are, I think, at the lowest, a 0.1 square miles. So some of these are getting pretty small. Sorry, I don't know, like 0.05 square miles.
Gotcha. And that's the only one about those.
Great. Okay. We'll roll through here. So I am bringing up now our mid-scale hydrologic condition index. This is something that we're still working on, but I think for those, especially in kind of the central Puget Sound area, and maybe this is more for the post prioritization phase, maybe really even going into the once you've got some select watersheds for a more detailed analysis, that phase of your SMAP requirements or moving forward. I did want to bring it up but it's still in development. Completed our proof of concept in 2019. I've got a grant to work on the next phase, where we'll start to build it out for all of the Puget Sound Basin and develop some of the tools around it to ultimately go through some planning level alternative future scenarios where you can look at build out and how it might affect things like stream flashiness, which is what this index really hones in on. It's its ability to predict likely stream flashiness, and we call those high pulse counts, which is 2 times the average daily flow, those events on the hydrograph that really spike up. And those, as many of you I'm sure know, have implications for BIBI stream bugs. So I wanted to just show you guys a little bit of this because I do think it potentially has a role, even though we're still building it out. Love to talk to you about it if you're interested in it. It really, the foundational pieces of this are Hspf model coefficients, where with an existing set of calibrated Hspf watersheds, King County ran every combination of land cover on till or land cover on outwash with 61 years of climate data. And so forcing those conditions to see what does that produce in terms of an average high pulse count. No surprise, low high pulse counts on average in a forested on till scenario, and much higher on, say, an all paved road on till watershed at 34 average annual high pulse counts. Here's what we did to start. We were doing this to look at different ways of kind of calculating the index. Don't worry about kind of the details of this. We don't have the time to go into it, but one of the things we did, we wanted to validate the index and different ways of calculating it. Here's a version of our calculation where we're looking at gauge measured pulse counts across 8 test basins where we had that gauge data, and then we calculated the index for those areas. And you can see the regression there is pretty decent. I bring this up because you know, that regression with high pulse counts allows us to extrapolate a relationship with BIBI, and the idea that and the demonstration, you know, that King County has done, and I think is fairly intuitive, that the higher number of pulse counts that occur in a watershed, the lower the BIBI score. So I bring this up to, again, tie into what I described with the work that was done, that we did with all of the BIBI delineated basins in Puget Sound, with our rod scale indices, our degradation indices. This hydrologic condition index, I think, has good implications and is useful for thinking about things like stream bugs as they're impacted by stream condition or flashiness. So here again is your SMAP sort of workflow, if you will. And this is underneath that workflow, where our different types of technical assistance or our different indices, I think, have the most value. So again, delineating basins, we've got technical assistance, we've got assessment units available for download. Our degradation indices really are, I think, most valuable under the assess receiving water conditions. Haven't really seen where we have much to support in terms of assessing stormwater management influence. And then as you start to get at the prioritization phase, that's when you want to bring in, you know, really the importance of that watershed, be it for water flow, water quality process, or for other things like salmonids or other critters of importance. And the management matrix can be a helpful construct for thinking about that, even if they're using other data than ours. So ultimately, that's where I think our technical assistance can be most helpful in your SMAP process. So we'll get into the tech support a little bit more specifically. So in terms of our level of effort and what we have in terms of capacity to support, you know, we're grant funded. We do have funding for a little while longer here, and we'll be searching for more. But for right now, we're a fairly small shop. You know, at the low level of effort, which probably most folks could get if you're interested in it, is, you know, the help, you know, navigating the downloadable data, our website, where you can learn about, you know, the indices and kind of understand them better. You know, really kind of getting at using that out of the box information that's really readily available. As we start to move into, you know, more tailored delineations where we're working with you and maybe a project team like that Manzanita example, that's certainly a higher level of effort. We'll be, you know, certainly consider those requests for sure, but we'll have to balance it with our other workload. and with the level of requests that's coming out. You know, where we're doing those tailored delineations, and you are interested in using our water flow or water quality models. Our general base deliverable is, you know, the geodatabase of the model results, and like a brief PowerPoint slide with some maps and some explanation of and an interpretation of the results at a rough scale. At the higher level of effort would be, you know, which we've done certainly, technical memos, you know, more detailed analysis, kind of really working long-term with the project team to integrate other data. And there's potential watershed visits and stuff like that that we can do. We don't take those on lightly though, because we try and do a really good job of them, and they take a lot of effort. So again, you know, we do have limited capacity, but we would love to see the requests come in. It's generally going to be first come, first serve. You know, we'll be prioritizing making sure people have access and getting at the out of the box data and kind of know what it is, so that we can really cast our tech support broadly. But if there are, you know, if jurisdictions come in and really interested in, you know, using our index data and not just kind of getting at the bare minimum requirements of calculating things like percent impervious surface and stuff like that, that's where we're really interested in, you know, investing in your SMAP process with, you know, some real tailored work on the delineations and the assessments and stuff like that. So please come ask for our support, and we'll tell you what we can pull off. We go real quick through the website, and then we'll just open it up for questions around the technical support piece and anything else. So here's our website. I'm not going to do the live demo, just given the amount of time. I think we're right about where we need to be, but I don't want to screw us up here. So you'll find it, Google Puget Sound Watershed Characterization Project, and you'll get there. Here is our website. Our publications, our kind of foundational volumes are up here under the Publications tab. Under the More tab, you can get the data. So that's where you'll get to our Ecology's data download site. And if you have any questions about kind of what you're trying to download or have any issues with that, please just get in touch with me. There's also super handy dandy layer gallery, which makes it really easy to get a sense of what the various different indices are. You have these, all of the different kind of sub indices and then the overall indices, which I presented today, have these little pop out boxes where it'll describe, you know, provide a bit of a narrative around what that index is and how it's assessed and what it means. There's some story maps, and I'd point you especially to the Mukilteo story map, which I gave you the kind of PowerPoint version of it, but we've got more information on it there, and I think there's plenty to learn from that story map. Then you can map the data. Again, version 1.0 is still on the kind of primary mapping portal, and then 2.0 is still beta. For the time being. As soon as we get those water quality indices up, we'll start making that the prime map portal that people can open into. With this mapping application, it's real simple. You can go through and just map the data, all the different indices, and zoom in, zoom out to where you want to go. There's also a cool tool where you can query the indices and the RIAs for different types of conditions. So in this case, I developed a simple query where we're looking at some of the freshwater index, which I didn't present to you today. So basically the value of these watersheds for freshwater habitats. So the top half of those assessment units for that. And then the most important areas for overall water flow. You press go on the query tool and it'll identify and kind of filter those out of the landscape for you to look at. There you go. Definitely want to acknowledge the National Estuary Program and the U.S. Environmental Protection Agency. They provided funding for our project for over a decade. So we wouldn't be here if it weren't for them, and we continue to be here because of them. So thank you. Okay, it looks like we have 11 minutes for questions, 10 minutes for questions. So Emma, if you can field whatever questions might be best now, happy to take them.
Yes. So the first one, how have land use planners and planning councils received this tool? And kind of following up, have you done any training specifically for this audience?
So for land use planners, yeah. So the planners receive it real well. Yes, especially back when I was getting started years ago. We definitely did the dog and pony show to a lot of the planners forums that were out there, and done a number of conferences, etc. One of the ways in which we've been able to bring this tool to land use planning it has been particularly because of the National Estuary Grant Program, the Watershed Lead Organization, which is in another hat that I wear, a grant program that has been in existence and is actually sunsetting this year for the last decade. And one of the buckets of work we did underneath that grant program was investing in land use planning related projects. And so in many of those, because we're kind of tied in as managing those grants, we were able to offer our technical assistance and our products as a part of those projects. So, I think planners really like it. I think there's some value to some simplicity of what we try and offer, while still bringing some robust, scientifically based information to land use planning. It's always challenging to move to see where this goes in land use planning, and so. When it gets to the, adopt this this plan, which has a bunch of other stuff in it, as well as our information for some comprehensive plan update or critical areas ordinance, there's a public process there that can be that can have it not, fulfill the goals of staff for reasons no other than that has nothing to do with the technical products. So. There have been some really good wins in terms of some innovative critical areas ordinance updates, and a lot of that, and comprehensive plans. A lot of that really has to do with is, do you have kind of the right champion on, say, a city council that thinks that this is the kind of information, this is the better way to plan for their municipality, and they want to drive through that public process. So it's a great question. I think folks really like it. There's the public side of getting land use planning done is always a challenge, and there are variables in there that have nothing to do with the technical product that you're coming up with. So, yeah,
absolutely. Next question, is the Columbia River getting a similar or related tool?
Right now, no. So our funding has been through the National Estuary Program, which is EPA's geographic funds, and so it's been just for the Puget Sound Basin. I've talked with others in my program about producing it for, developing a similar product for other parts of Washington, and we're interested. They're interested. Funding is always, the challenge of that, but the more interest can be expressed along those lines to ecology, the more likely that might happen.
Cool. Very good. What's the general time frame to update version 2.0 with water quality data?
Yeah, so I think I mentioned, so I'm literally like next week reviewing some of we've had to reconstruct this without getting into the details. We've had to reconstruct the software in ARC Pro because they started using an open source software, which we couldn't use because it had there's some bugs in it, and then there was actually potential for really bad stuff to happen to our network computers. So we've had to reconstruct the whole model. So that's what's kind of slowed us down. I hope to have them out in the next, I think, 2 months. Those are my aspirations, at least. We're on the home stretch.
Good, awesome. That's good to hear. I'll give it just another minute to see if any final questions trickle in. But while we're waiting, Colin, do you have any final thoughts, inspirational quotes?
I should have come with one. No, I do hope that folks, if you're at all interested, just contact me. love to have conversations about this, even if there are, we don't end up using our information. Love to discuss your project, and I hope there are some ideas that came through in this presentation that, irrespective of using our information, they help you think about these upcoming requirements and the process of addressing those parts of the receiving water assessment, and what's out there. Our information is one source of accomplishing those requirements. Certainly not the only one, but I think our framework has some value, even if you just want to talk through it. So yeah, please reach out.
Good, thank you. Well, it doesn't look like we have any more questions then. So just want to thank you again, Colin, for this session, this presentation. That was really helpful to a lot of people. And yeah, your contact information is there, but I think we can go ahead and end the session.
Great. Have a great rest of your session, and thanks for having me.
All right, thank you.